If you make crosswords, then you probably use a scored word list to help you source your answers. A typical New York Times 15 by 15 puzzle will contain about 75 words. But in order to make a crossword, constructors will draw from lists of hundreds of thousands of words, and use them to help fill in the blanks when they get stuck. To give you a sense of scale here, Chris Jones' word list, which I've linked down below, contains about 170,000 words, and there are many other free-to-use and paid word lists available online. But why should you care? Well, for many of us, the word lists that we rely on aren't perfect. They often contain words that are theme-sensitive, or they have spelling errors, or they use British spellings, which aren't always accepted here. Now, full disclosure here, I've never actually had a published crossword, at least not in a newspaper. But I have been working on a couple of particular crosswords that I hope to make the subject of future videos. What ends up happening, especially as you start adding more and more themed words, is that completed fills become harder and harder to come by. This makes it really important that your word list is full of words that you like. That way, you're not stuck waiting around for something that is just going to disappoint you when it appears. This idea of separating words that you like from words that you dislike is the main idea behind the scoring system, and different word lists use different scoring systems. These scores tend to be generated algorithmically using heuristics like the number of occurrences of that word in previous puzzles, or on web sources, or the number of published clues for a word. But this idea that you need to use a computer to score the words is really a function of the scale of one's word list. So to give you an example, if you were to score one word by hand every 5 seconds, it would take you about 730 continuous hours of labeling before you made it through Peter Broda's word list with 526,000 words. But these scoring algorithms that operate on word frequency and puzzle frequency, they don't necessarily turn out great scores. Remember British spellings? Well, they tend to use a lot of those in Britain. And remember Chris Jones? Well, Chris actually sourced many of his words from Peter Broda, and he mentions that the scores are not great. No, I do not blame word list constructors when bad scores arise in a word list. First things first, bad scores are not really real. Somebody else likes a word more or less than you, and that's okay. And also, these scores were generated by a computer anyway. If anything, word list constructors do a great thing for the community, especially if they make their word list public. But my growing frustration from finding and dealing with these dislikable words in my word list convinced me that it was probably time for me to make my own, or at least make a scoring algorithm that I could use to score words based on my personal preferences. So to do that, I turned to machine learning techniques and AI tools. It took me about 3 months, but I finally have a word list that I'm proud of and that I'm ready to distribute. For the remainder of this video, I'm going to be talking about that project. I'm going to talk about how my scoring algorithm works, where you can find my word list, and how you can use some of the tools that I built along the way. That's it. I hope this is a very informative video, and I hope it's a fun watch. So I started not by trying to make a word list, but by trying to construct crossword puzzles. I built my own search algorithm and a visualization tool that would allow me to quickly search through possible fills. When I found a word that I liked, I would manually approve it and add it to my list. When I found a word I didn't like, I would manually reject it. So to date, there are about 622,000 words in my word list database, of which I've marked 29,000 as approved and about 14,000 as rejected. I'll let you do the math on the number of hours here. Next, I used what's called an embedding model to vectorize my sorted words, together with some possible clues that I found online. Now, if you're not familiar with embedding models, they are a class of AI models that are very useful, but often overlooked. Everyone thinks about the large language model, like OpenAI's GPT suite or Anthropic's Claude models. And the way that LLMs work, like at the highest level, like I'm explaining this to my parents, is that they take text as the input, they convert it to numbers, and then they convert those numbers back to text at the output. I promise I know what I'm talking about, but I'm not going to get any deeper into how an LLM works. Now, every experiment I've run in my life has taught me that you should not ask an LLM to explicitly provide scores for your writing. I've done experiments with emails, text, blocks of code, but I've never really been able to differentiate the output from noise. I have gotten good results out of what are called embedding models. So, unlike large language models, embedding models take text, turn it into numbers, and then stop. But here you can study the numbers to understand the input's relation to other words, at least within the training set of the model. Now, I say study the numbers. This is because embedding models really respond with collections of numbers called vectors, and the output dimension is very, very high here. So to give you an example, OpenAI's Text Embed 3 model, which was the one that I used in this project, returns with vectors of length 1536. That means every time I put a word in at the input, the output will be about 1500 numbers that we now need to analyze to figure out the correct score. And that's really where it started. I took the 43,000 words that I had hand-labeled, and I converted them to vectors using an embedding model. Then I trained what's called a support vector machine on the two sets of vectors in order to separate the words that I approved from the words that I rejected. Now, if embedding models are AI, then support vector machines are traditional machine learning, like traditional textbook, you learn about SVMs in college. The job of a machine learning mechanism is to fit a model to data. And the simplest ML model is the linear regression model, where you start with a collection of points and you try to fit a line of best fit through those points. The support vector machine idea takes this in a different direction. So you start with two sets of points and then you train a model to learn the line that separates them. In the case of my model, that line was actually a plane, and it's in this 1500 dimensional output space of the embedding model. Now, any AI expert here is probably thinking, why did you use an SVM? And there's really no reason to assume this would work going in. I don't know how Text Embed 3 was trained, but I know that its outputs live on a hypersphere, and nonlinear models with spherical output spaces and separating hyperplanes are not necessarily supposed to work together. They're not best friends in mathematics. But the training results were actually pretty good. I trained 7 total SVMs using different choices of hyperparameters, and the last one had reasonably good accuracy across the train and test sets. In the end, I decided I would use an earlier model when I realized I could get away with almost no false negatives if I allowed for a slight increase in false positives. And at that point, I ran the SVM across all 622 words I started with. I did a couple of transformations on the scores, and I saved a refined word list of about 400,000 words whose scores seemed right to me. And that was the project. I'm going to flash up some of the resulting words and their scores here. If you're interested in checking out my word list, there is a link down below in the description where you can check it out. And if you're a little bit more technical, you can clone my GitHub project and train your own SVM to score words based on your preferences. So, full disclosure here, my model scores are not perfect, and you'll likely notice this if you go check out the list. The model's role for me is largely to reject the words that I don't like, and while there are more than a couple of false positives, the new word list has really sped me up. I hope it brings you the same value. So with that, I'd like to thank you for watching. I hope you go check out my word list, and I hope to see you in the next video soon. Thanks again.